Hi students, now we are going to explain a theorem in physics which is called as Work and Kinetic Energy Theorem. It is a very popular theorem and for examination also it is very important. Now I have considered an object of mass m which is moving along a straight line, and when it crosses a point A, its initial velocity is u. It is moving on the way. I am choosing 2 points A and B. So when the object approaches the point A, its initial velocity, its actual velocity is u. At the same instant, I am applying a constant force F on the object. So what will be the effect of this force on the body? It may change the direction of motion, it may change the speed of the body or velocity of the body. But I have considered that the force acting on the body changes only the magnitude of its velocity and not the direction. So that the body is increasing its velocity from u to a value v when it approaches a point B. That means the force acting on the body of mass m has changed its velocity from an initial value u to a final value v in a time t, let us say. Okay, so that between the initial point A and the final point B, the body has moved along a straight line and its displacement is s. Okay, so what will be the work done by this force? As usual, children, work done is equal to the dot product of force and displacement. And in this case, force magnitude is F, displacement is S, and the angle between F and S is equal to what? 0. Therefore, W is equal to F into S. This is the first equation from the definition of work done by the force. Okay? Then what is the mass of the body is m. Is the body accelerated? Yes. Why? Because its velocity has changed in magnitude. So when the velocity of the body changes, then the body must have an acceleration. So that acceleration is taken as a. So from Newton's second law I am applying. Okay, from Newton's second law, F is equal to m into a. Therefore, instead of this m, I am going to substitute m into a. So W is now taking a new form. Instead of F, m, a into s. So this is our equation number 2. So we have applied Newton's second law for the force F, and we have arrived at equation 2. Okay, children, now we have studied some equations of kinematics, isn't it? So equations of kinematics we have studied. The 3 basic equations we have studied, isn't it? The third equation is what? The third equation. So from this I am taking the third equation. V square is equal to u square plus 2as. This equation I am considering. Understand that? So what is v square minus u square is equal to 2as. Now this a into s, here also a into s is there. So by 2 we can take, or otherwise this acceleration also is equal to v square minus u square divided by 2s. In this form also we can relate. Okay, so the acceleration of the body is equal to v square minus u square by 2s. I am going to substitute for a here in this equation. So let us take this as equation 3. Now equation 3 applied in 2 implies W is now equal to m into a. So instead of a, what shall we write? V square minus u square divided by 2s into third factor is s. So now this displacement S is getting cancelled. Therefore, now W is equal to M into V square by 2 minus M into U square by 2. So this is equal to half M V square minus half M U square. So this is V is the final velocity at the point B. Therefore, half mv square must be the final kinetic energy of the body. So this is equal to what? Kinetic energy final minus u is the initial velocity at the point A. Therefore, half mu square must be equal to what? Initial kinetic energy of the body. So this is kinetic energy initial. So final kinetic energy minus initial kinetic energy only is called as what? Change in kinetic energy. That is delta K.E. Therefore, the work-energy theorem states that the work done by a force acting on a body, the work done by the force which is acting on a body changes the kinetic energy of the body in words. Okay, so this is the statement. In mathematical form I have written W is equal to delta K.E. Children, that kinetic energy is only the change. It may be an increase or decrease. So based on that, whether the kinetic energy increases or decreases or remains the same, there are some implications. You have to write in the exam those points also. So what are the three implications we come to know from this theorem? The first implication, let us say that the kinetic energy, or else we will take the left hand side. So the work done may be positive. So when the work done is said to be positive, what? There is an increase in the kinetic energy. So this change in kinetic energy is positive. That means kinetic energy increases. Okay. Now implication number 2, the reverse of this case. What will happen if work done is negative? So if work done is negative means then the change in kinetic energy also will be negative. Therefore in this case what? Kinetic energy decreases. Okay. And the third case. So in the third case, so W is equal to 0. So change in kinetic energy. Change in kinetic energy is 0 means then the kinetic energy, therefore kinetic energy remains constant. These are the three possible cases. So my dear students, what we have studied is we have considered an object of mass m which is moving from an initial point A to a final point B under the action of a constant force F. So when the force just acts on the body, the initial velocity was u and the final velocity after reaching the point B is happened to be v, and the displacement S is taking place. So the work done by the force, we have started with the dot product of the force and displacement, and then we have arrived at an equation W is equal to delta K.E. So which gives the statement of the work-kinetic energy theorem. This states that the work done by a force acting on a body is equal to the change in kinetic energy of the body. With the three implications, I hope you must have understood well. Fine.